Hello everyone, welcome to this video. This is lecture number 89. You already know that 88 lecturers covered and description given the link. You can watch this. Actually, we want to solve the supplementary problem of this book Vector Analysis by M.R.Spiegel, and in this video we want to discuss about the supplementary problem 8.77 to 8.86 of chapter 8, which consists not curvilinear coordinate system, sorry, this was the tensor analysis, right? This is actually previous chapter which already covered. You can watch the previous chapters by the link given in the description box. So let's start with question 8.77, which says that write down each of the following following using summation convention. Okay, so if you want to write into the summation convention, you want to watch where is the repeated index. Here you can see this one are changes, two changes, but a3 is constant. So this 1 to n up to this is the dummy index, and this is called 3 is the free index. So if you want to write it in the summation form, you can write in this a j x to the power j x3, right, where j runs from 1 to n, and in summation form you can just write as aj x to the power j x3. Here j is the dummy index, and this 3 is called free index, right, free index. Similarly, if you want to write for b, you can write this is a, you can see 2 is constant, so 2 right here, and 1 to n, so this is right as j, and b 1 to 3 n, so this is j. Similarly, for c you can write aj already given at 1 to 2 are changes, so this can be written as suppose k, and this is k. Similarly, for d you can write g21 g22, so g2 is constant and this will be changes, so you can write as j, and then g1 1 2 1, so 1 is constant and there is j. Clear? This is 1 1 2 2 and so on. And for e you can see here, that is b 1 1 2 2 2 2 2 1 2 1 2 2 1 2 2. So this is actually written is the middle 2 is constant, so this is 2, but here you can write here this is the index, suppose I, and this also change j, and if this is I, this is also I j, right, where I and j change from 1 to 2, j change from 1 to 2. So this is written as n equals to 2. There is only 2 number. Clear? This is the summation notation. Next, 8.78 says write down the terms of each of the following indicated rotation. This is the inverse of the previous question. Here we summation summarized, and here the summation can be elaborated, right? So del x to the power k root z a k, where k n is 3, so you need to write 3 terms. So this is x to the 1 root g a to the power 1 del x2 root g a to the power 2 plus del x3 root g a3, right? Similarly, for b, here written as ajk bkp cj. Okay, here n is changed from 2, so here two variable j and k, so change is j 1 to 2 and k 1 to 2, so you can write a1 1 b to the power 1 p c 1. plus B1 2, K as a 2, so this is 2 C1. Similarly A2 1, so K is 1 P, not K, this is P C2, and A2 2, so this will be 2 PC2. Clear? Just put J equals to 1 to 2, J equals to 1 to 2, K equals to 1 to 2. Right? Third says that J x bar J del xk del xk del x bar m. Right? So this can be written in the from this is changes, J and K both are changes, so you can write sorry, there is K is repeated, so this will be the dummy index, so this can be written as del x1 del x1 del xm plus del xj bar. This bar means transformation, we will 2, and this is 2 del xm bar, and up to n terms del xj bar del x to the power n into del xn del x to the power m bar. This is the index. Next, this says what locus is represented by this. What locus will be represented by this equation where k equals to 1 2 3 n regarding this, taking n equals to 2 3 and 4. So at first if we take n equals to 2, if we take n equals to 2, what will be the equation? A1 x1 x1 plus A2 x2 x2 plus A3 x3 x3 equals to 1. So if you write this is A1 and this is x1 square, this is taken as x, this A2 this is taken as y, and A3 n is 2 n is 2, so only 2 term, this is not valid. So you will get these two equation, and you can rearrange this as x square by a square plus y square by b square equals to 1, like that. So this is the equation of ellipse. Clear? For n equals to 3, what will we get? Similarly a11 x1 x1 a2 x2 x2 and a3 x3 x3 equals to 1. So this can be written as a1 x square a2 y square a3 z square equals to 1. So this also written as x square plus a square y square by b square plus z square by c square equals to 1. This is the equation of ellipsoid. This is the equation of ellipsoid. And for n equals to 4, then this will be like that. That is 4 terms arises in this equation. So a4 x4 x4 equals to 1. So this is a1 x square a2 y square a3 x square z square plus a4. This can be written as ct whole square equals to 1. So this is a 4 dimension. This is actually a hyper ellipsoid. Hyper ellipsoid. Done. Clear? Go to the next one. This question says that let n equals to 2, write down the equation represented by this. So you need to write two terms. Clear? So if you write the two term, that is a p is taken as 1, q is taken as 1, so x1 equals to plus a 1 2 only 2 x2 equals to b1, and if you take p equals to 2, so this is p2 q1 x1 and q change to 2 to the p equals to 2. So these two are equation found from this equation, the notation. This is the summation notation and this is the extent from expressed. Next, write down the law of transformation for this tensor. So if you wants to write down the transformation in case of first one, so this can be written as EQR, transformation represented by bar. So in right hand side this will be IJK. So this p is upper, so you need to write xp here, and p is I changes from p, so this is xi. Similarly q is upper, so del xq bar means transform xj, and r is lower, so you need to write r here and k here. Clear? Next for b, this is b I j k, so p q r s. So in that side b I j k m, so you need to write del x p bar del x I del x q bar del x j and del x r bar del x k, and this is x is lower, so del x s bar del x m. Clear? Next c m m, so you need to write c m n, so you need to write some p q like that. So this is lower side, so this will be xp and this will be xm, this will be xq, this bar, and this will be xn. Clear? Next am, so am bar equals to m naught, this m will be changed to p, so this will be x p bar and this will be xm, not p here, p in the contravariant position, so m can be written here. Clear? This is the transformation of the tensor. This is the transformation property of tensor. Next, suppose, sorry, oh no, suppose the quantity this b and c transform from a coordinate system xi to xi bar according to this law. So determine whether they are tension. If so, write down the tension suitable notation, give the rank, covariant, contravariant, etc. So if I just want to write for one, that is given as like b bar equals to del xj del xp bar del xk del xq bar del xr bar del xm into b. So you can see here j x p p is lower, so p here, q here and r here, and in that case this is I here, sorry, j here, k here and m here, like this is the transformation. So this is satisfy this equation, so this is a tensor number 1. For suitable notation, this is the suitable notation, and give the tensor notation is written as j k m, and rank is 3, and this is the contravariant and this is the covariant. This is the contravariant, so contravariant of order, there is two contravariant, one contravariant, this is one contravariant order 1, and there is two covariant of order 2. Clear? But in case of this you can see here, that is C del x p bar del xj del x q del xk bar del xm del xr bar del xs del xn bar. Clear? So if you wants to write, so you can write here p, here this is k, so here k, k here, r here, n here, and here will be p, no p, j q m s, okay, like that. I think clear. But here you can see the function given as p q r s, or here given j k m n, but j k m n, but we see these are not satisfy this condition, so this is not tensor, not tensor. Clear? Here we can write the as given function p q r, and here the given function j k m, but this notation gives you the different from as given is not obtained, that's why this is not a tensor, right? Next question, how many component does a tensor of rank 5 and 4 dimension? So number of component of a tensor, equals to the n to the power k, where n equals to number of dimension and k is the rank of tensor, So here number of dimension 4 and rank of tensor is 5. So this will be 4 to the power 5. Next question, prove that if the component of tensor are 0, components of a tensor are 0 in one coordinate system, they will be 0 in other coordinate system also. So in the coordinate transformation like that, if you take a fourth order tensor, so you can write this as like that, x q bar xj and x del x r bar del xk del x s bar del xm, this is a ij k, right? So you can see if this will be 0, if this will be 0, then obviously this becomes 0. So if one component in one coordinate system, this will be the one component will be 0, then another coordinate system with respect to another coordinate system, this will also 0. So you can say if a I j k m is 0, then a p q r s also 0, also 0. So you can say uh, the above statement, right? Statement. Go to the next one. Prove that if the component of two tensor are equal in one coordinate system, then they are equal in another coordinate system. In the previous, just like a previous process, if you take two uh, for this is A, if you take another B, so if A and B are equal in this coordinate system, then also in this coordinate system these are two must be equal. right? This is the same just for previous process. Take two one, that is PQ and RS, and another BPQRS, right? So you can write here, and this IJKM, and similarly this is at the BIJKM. If these two are equal, then obviously these two are also equal, similar. Next, so that the velocity of a fluid is a tensor, so that this velocity of a fluid is a tensor, but this is not a tensor. So velocity dxk dt equals to vk, right? So if you change in vector from like another vj, so this is xj in that system. This can be sorry this can be written as like that. So this is nothing but vk. You can write in differential form because this variable will be, so this will be like that. So this follow up the transformation of tensor, so this is a tensor. But in case of that, if you take dvk dt as a ak, take as ak, so you can say similar process aj will be dvj dt. So this is nothing but del vj del vk, and this is dvk dt. So you will get del vj del vk into ak. But this not satisfy the transformation, because is not transformation, you need to get formation like that, okay? But you did not get like that, you get this one. So these two are not equal, these two are not equal, so this is not tensor, 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 right? I think clear. For any doubt you must comment in the comment section. This is all about me, and this is my contact details, and this is my YouTube channel details. Go to this channel, you get the video which already uploaded. Share this video to your friends so that he or she also get benefit, and subscribe this channel if you new in this channel. Press the bell icon to get the notification of upcoming video. You can check my YouTube channel, you get the others part of physics also, okay? So take care, we'll meet in the next video as soon as possible. Thank you.